Hello everyone. Today I'll be teaching inductive effect. Now there are 5 things about inductive effect which we should know before I proceed. Now the first thing is it is not resonance dependent. The second one is it is distance dependent. Okay? So it is not resonance dependent but it is distance dependent. It depends upon the electronegativity of the group attached. Okay, so these both are interlinked. So it depends upon the electronegativity of group attached. And it travels through sigma bond. It travels through sigma bond and not the pi bond. You have to remember these 5 properties before we proceed. Now, let us take a few examples. I'll take a few examples to explain it a little better to you. So the first example I'll take is CH3Cl. Now we all know that in CH3Cl, the more electronegative atom is Cl. We all know this. Cl is more electronegative. Electronegativity is higher than, of course, of carbon. So it will attract the electron density towards itself. What happens is when it attracts the electron density towards itself, this becomes delta negative, gains negative charge because it is withdrawing the electrons from carbon. And carbon, because it is giving electrons, gains a positive charge, delta positive. Now we can call this electron withdrawing. Okay, and we can call this as electron donating. Now, because we are doing plus I and minus I effect, that is inductive effect, we'll say that this one here, Cl, executes minus I effect and CH3 here execute plus I effect. So this has minus I effect and this has plus I effect. This is on the basis of, as I'm explaining to you, this is on the basis of electronegativity. So just going through it, Cl, which is more electronegative, it attracts electrons toward itself from CH3, becomes delta negative, more electronegative, so it becomes delta negative and executes minus I effect. Coming to the next example that we have, this is based on distance. So this I'll be explaining on the basis of distance. Now, as you can see, this is similar to the previous question, but we have added 2 more carbon atoms to the chain length. Now, what happens is Cl, we know it is electron withdrawing group as evident from the previous example. So this is an electron withdrawing group. So of course it withdraws electrons from CH2 from here as well as here. We can name these carbons as first carbon, second carbon, and the third carbon. So these are 3 carbons named accordingly because of the distance from the chlorine atom. So what happens is we know that Cl, because it is electron withdrawing group, we know this executes minus I effect as discussed previously in the previous example. So minus I effect is shown by Cl. So what CH2 does is, of course, all of these will show plus I effect. But the thing here is that plus I effect, they'll show plus I effect, but to a different degree. What happens is, since this Cl here, this CH here is nearest to the Cl, which we are this which is being discussed. So this CH2 actually has the highest plus I effect. So plus I effect is maximum in this CH2, which is the first one which we have marked. Similarly, as we go on increasing the distance, this plus I effect is decreasing, and this carbon, the third one, will have the least plus I effect. So, can we now not put them in ascending or descending order? So, let us put them in increasing order. So, first is greater than 2 is greater than 3. This order is of the plus I effect, which is being shown by the different carbon atoms. So, plus I effect, if the first carbon, I just highlighted for you for better understanding. So this CH2, the first one, is greater than this one, and this second one is greater than the third one. So it is very evident from this that first is greater than second is greater than third. So this is the order of the plus I effect.